Hello, welcome everybody. Thanks for joining us for today's TREP 2020 Roadmap webinar. My name is Matt Eddy. I am the business owner for real-time delivery and integration at Refinitiv, and I will be your host for today's discussion. Before we kick off, I'd like to cover a few housekeeping items on how to use the platform, how to interact with the team. I think at the bottom of your screen, you'll see application widgets that you can turn on or off, and they're going to control your webinar experience. So have a play with those, work out how you set the windows up, etc. We'd suggest you at least keep the slides widget and the media up. The media is going to be where you'll see the demos that we'll be doing, but you'll also have a chance to see all of our beautiful Hawaiian shirts that we've hopefully all got on still, and not just me. If you've got any questions during the webinar, you can click on the Q&A, submit your question through there. We may or may not answer it there and then, or we may wait until the end. So just do be patient on that, because we've got a lot of material to get through, so it might make more sense to go through to the end for those. We do want to encourage all of your questions, though. We'll try to get to all of them. The ones we don't answer, we'll try and follow up with one-on-one or online at a later date. Also, please note, we'll be sending you a recording of the webinar after today. So if you want to speak to anyone from Refinitiv about what you've seen, about what you've heard, if you want to have follow-ups, then please do provide contact details. And you can do that at the survey at the end. Okay, so let's move on to the first slide. So as you can see, the agenda slide up, hopefully, in the main screen. I'll spend a couple of minutes just talking about where we are today, what we've got on, why we're doing this over a webinar rather than in person. I think everyone can probably guess. I'll step briefly through what the team is that will be presenting today, and then I'll also go through briefly what the agenda items will be. So in terms of what we're doing, obviously the top story is COVID and the impact to our customers, and any kind of questions you've got, or anything that you might want to relate back to current issues around performance issues, around BCP or disaster recovery plans. Those are absolutely relevant, and we'll try and touch upon some of those as we go through as well today. We've also got a lot of interest in what we're doing around moving to the cloud, how we're supporting our different software environments, and so we'll be mentioning that quite heavily through today's presentation, and if you've got questions about that, please do fire them around. In terms of what we'd hope for from the customer advisory forums in 2020, for those that have previously attended these forums, it's been a chance to work directly, to hear straight from the developers, from the architects, from the product managers, exactly what we're doing, hear the roadmap. And what we'd hoped to do for 2020 was evolve that a little bit and talk much more about what we're doing strategically, what our reference architecture looks like, an update on what our managed services environment will be, and about our cloud readiness as well. So there's a lot of that really we wanted to do in person. What we thought was important, though, was to still carve out the roadmap item, because this is something that's relevant for everybody, and figured we needed to get that information out there. Okay, so as the global situation changes, we'll keep everyone informed of the latest events and whether we'll be doing these in webinars or in person, and you can find out more as we know. In terms of what to expect today, like I mentioned, unfortunately this isn't interactive as we'd like, but we'll walk you through the roadmap. We've still got several live demos that always make it exciting and interesting, and you'll have a chance to listen to the experts that are architecting, developing, and supporting the products. We're still really seeing it as the most important conduit that we've got for our customers, so please do let us know what feedback at the end in case you want a change in agenda, you want to see more or less of certain things. As also mentioned, the Q&A at the end, we'll try and walk through that, and we've all got ourselves ready to go for that, so post as many questions as you do want to. Okay, I'll just briefly step across to the team slide. For those that have heard from us before, some of the names you'll recognize. Out of the list on the screen, though, today you're going to be hearing primarily from Jeff Sewell, who's the product owner for TREP, Joe Miller, who's the lead developer for TREP, Mahesh Bommanayaka-Nahali, who's the third level support for TREP, and Brian Sandry, who leads the real-time dev teams out of Oak Brook. Of course, we've got a global set of development teams, but Brian himself and most of the team here are based in Oak Brook. supporting those folks today, and hopefully in the FAQ are some of the names you'll also see on the screen. Okay. So before we move across to the roadmap, wanted to check a couple of things. One was ask a question, which is up on the screen now. And this is also just to make sure that you're all aware of what we're doing around polling. So there's a couple of questions we'll drop in to the session. So as you can see on the screen, we've got a quick question for you just to get the ball rolling. It's you can vote as soon as you're ready, submit, and we'll see what you get. So have you started exploring running TREP and or DAX and or any of the other real-time components in the public cloud? So what you'll see, the answers there, you'll see not something we ever planned to do, something we've discussed but not yet started, we've been exploring how they work in the cloud, or for those probably in the minority at this point, we've got everything containerized and orchestrated to fire up in our cloud already. So once you've got the option that's most applicable to you, submit it. It's all anonymous, so we're not going to track any of the data. I'll produce a result just showing the voting results, and it'll just be the first one we do. We've got a couple of other questions lined up. So I see we've got a few people that have already voted. I'll wait for a few others to get going, and then I'll pop the results up on the screen, and then we can see whether this is a surprise or not. Okay, all right, so we've got a good number have already voted, so let me flick to the results. And I guess for most of us, that's something we probably expected. By over half, 56% have said something we've discussed but not yet started. I think that's probably in line with what we've heard. And in terms of customer numbers, we've got a smaller amount of customers are quite evolved and quite forward in their thinking. Most are exploring or discussing at this stage. So a lot of what you'll hear today will actually help you with those, because it'll talk around how we're also preparing ourselves for the cloud as well. And it's some of the tools, some of the capabilities, monitoring, management, configurations, etc., that will help you get there as well. So with that, I will now pass the microphone across to Jeff Sewell, who's going to run you through the first page of the roadmap. I'll step onto that. So Jeff, if you're there, then please do take over, and I'll hand the mic over to you.
All right, thanks, Matt. Good day, everyone. Thanks for joining us today. Although this is obviously much more abbreviated session than our normal CAF, we've got a lot of information to cover, a lot of details to cover. The objective here, again, since we're not together face-to-face, is at least give you an idea from a roadmap perspective what the deliverables are for this year, so you can plan accordingly, understand what's coming, timelines, and then obviously if you have questions or ideas, then please let us know. This is, again, we don't have the interaction, but you can certainly comment on in the chat room, right? So as Matt said, the roadmap's 2 pages. I'm not gonna keep you on for 2 full pages. What I'm gonna do is I'm gonna run through the first page, and then what we're gonna do is segue into some demonstrations. Joe's got 3 or 4 demos for us that he's gonna do, which basically validates that what we're delivering actually is up and running and working. And then what we're going to do is we're going to have Mahesh give us a preview. He's got a second quarter deliverable, which is the ADS POP Performance and Tuning Guide. Again, he's got a couple months to go, but we're going to give you a preview there of what he's working on. There will be a survey question there looking for a little feedback and direction. So again, feel free to submit any questions along the way. All right, so let me get started. First, what we're going to look at is there's 2 large enhancements that will be available this month, which are asymmetrical load balancing for the ADS POP, or ALB as we call it. And then also we have level 2 map conflation, which is also due here at the end of the month. Asymmetrical load balancing for the ADS POP, what it is, it does exist already. It's just not a feature on the ADS POP. And so what it does, it allows you to assign a cost factor for each ADS POP you're running. And then basically you can use that as a traffic management tool. So the cost factors you assign to a server are 0 to 3, with 0 being what would be your lowest cost server. So your lowest cost server essentially would generally be the server that's most local to you versus maybe a higher cost server that goes out of the organization to another data center or something like that. So it's just a tool that people have used and they've asked us to add it to the ADS POP. So the benefit of the feature is really pretty simple. Any requests that are directed to the ADS POP, basically the ADS POP that has the lowest cost recognized as configured by you will get all the requests first. And Joe will run through this in terms of the demo. Basically, the configuration goes up to as high as 95% of the usage of that ADS POP before it rolls over to the next cost model. All right. So that's asymmetrical load balancing on the POP, ADS POP. And then the next deliverable this month, we have level 2 map conflation. It's an optional conflation setting that will apply to the maps of the field list. And this now will include across all domains, including even custom domains. So this is for anybody that has a custom feed that wants to conflate some of that data. You can do that as well. And this will be specifically for the add, delete, and update actions. And benefit, again, with any type of conflation is that can be configured is for all non-level 1 data now, you'll be able to conflate these 3 action types, and this will reduce network traffic. All right. There's also a number of small enhancements this month that Joe's going to actually provide some details on. There's some addition to some conflation. There's some improvements in aggregation that he's going to hit on and do a couple demos on. All right. That's, again, this month, those will all be delivered. Right. Moving on to the second quarter deliverables. Next one on the roadmap you'll see is ADS POP Performance and Tuning Guide. That is the tuning guide that I just mentioned earlier. ADS POP was originally introduced as a fan out and caching server. Many customers have told us that it's become a very integral part of their TREP infrastructure. They've asked us to add more features, which we certainly have done. The Performance and Tuning Guide is not a new document that Mahesh has produced, but we have not produced one for ADS POP, so Mahesh is working on that now. The objective here is to give you performance metrics for the ADS POP, what you can expect in terms of trying to scale out the servers, and then what would be optimal configuration settings. The benefit, as you can assist, and as you can imagine, basically is getting you basically the highest throughput we can through the ADS POP. The numbers Mahesh is going to give you will give you an idea where we're going, and we've certainly taken in your feedback from the last CAF where we had discussed the last performance and tuning guide, basically you'll understand more how to scale, how the ADS POPs will scale under load. That's the important part. That's the important objective there, right? Also, end of second quarter, we have map entry-level entitlements. This has certainly come from a request from more than one customer. Basically, this feature will enable the ADS and the ADS POP to go back and check the map entry lock per user against DAX, and then filter that user's entitlements with more granularity. Right. So what it means is that the benefit is you can better manage end user data that you have more control now. Obviously, with entitlements, what we're trying to do is reduce exchange fees and compliance issues. But this will also allow someone, for instance, to build a blended order book. If you had, I don't know, 6, 8 venues that you're receiving, but not all the users accessing that data are paying for all 6 or 8 venues. Basically, this will allow you to build a blended order book based on what those users' entitlements are. So that's a useful feature we're bringing out here. All right, the next one down, number 5, we're up to here. ADS POP cascading warm standby. Extending the warm standby feature to the ADS POP, cascading ADS POP. Basically, what it'll do, it will direct requests to the cache of an active and standby server simultaneously. So what will happen is, in the case of a failover, the recovery time will be reduced because the watch list will be synchronized on both servers, right? So that's the objective of that enhancement. where are we now? No, all right, number 6, we're down to now Q3 deliverables. I'm going to run through this one, and then we'll take a break from me and move over to Joe. Number 6 is REST phase 2. Everybody's well aware of phase 1, which we released earlier in the year. Phase 2 will be encryption and snapshots. Here we're giving you 2 for the price of 1. So what we're going to do is we're going to extend the REST capabilities by offering encryption now on the REST connections. So if you're using REST, let's say you're remotely accessing a server, at another data center or something like this. Basically, what it does is increases the security and reduces the need for customers even to set up proxy servers. That was one of the reasons why people were asking for the encryption, so they didn't have to set up these proxy servers. So again, we listen. You guys have some great ideas, so keep bringing the ideas to us. We'll certainly incorporate what we can, implement what we can. And then the other part of the phase 2 is we're going to provide the ability to be able to make snapshot requests using REST. This is something that was brought up at one of the casts. We thought it was a good idea. So basically what it means is you'll be able to use REST to make snapshot requests, and you don't need to be an adroit programmer now to basically go out and pull in snapshots. So that's the point of encryption and snapshots on REST phase 2. All right, I'm going to take a break here. I'm going to turn this over to Joe. Joe's going to go demonstrate some of these new features. And go ahead, Joe, take over.
Yeah, thanks, Jeff. I'm going to flip to the next slide. So I think I just do this. Everybody see that? So I have a quick slide there. I think Jeff did a great job of describing the feature. Those of you who've been around TREP for 20 years know we kind of have this built in the ADH and ADS already. So it's really the same functionality. As Jeff said, we're trying to focus on bringing all that TREP functionality into the ADS POP for you guys, or as much as possible anyways. And then this was a customer enhancement that we were asked of. And then we're using it internally as well as ERT Cloud. So this is one of those things that benefits both us and you guys. So as Jeff said, we have costs. All your costs today are default 0. And then you can do different cost groups from 0 to 3. Again, we'll transition through each cost group as the lower cost group becomes utilized. Everybody's favorite parameter, normalized low-level threshold for current requests, defaults 95%. So once all the servers in the lowest cost group reach 95%, at that point we'll start moving forward. If a cost group isn't there and 1 becomes your lowest cost group, we're gonna go first. So I'll do a real quick demo for you guys. Let me do a screen share here. Can everybody see my screen? My terminal windows?
No, not yet, Joe.
There we go.
There. So I think you guys can see my terminal windows now. I'm just gonna run a simple test, sort of out of the box, 341. And I'm just going to set up 4 different servers. So my route list, I'm going to have 4 servers. Something I try to tell people, which is really easy, you guys can scope the route globally if you want. So that's what I did here. I have 2 servers going, 1 test server on 14,023, and then I have the other 2 servers going to 14,024. So I'll have 2 RMDS test servers running. And then the configuration, I have, my cache is kind of busted up right now. So my 1 and 2 are my lower cost group, and then my 3 and 4 are my higher cost group. Right now, I'm kind of limiting my local cost group based on capacity. So this is one scenario where you want that local feed for the first, whatever capacity max cache you want. And then at that point, only when you start to exceed that, do you want to go to higher cost groups. So that's kind of the demo I have here. Obviously, your capacity doesn't have to be limited on capacity either. It could be sort of a resiliency play, right? Where you have your local feeds where you want everything to go local unless there's an outage. We obviously don't have BG backup in the ADS POP. So this kind of gives you that sort of live resiliency that you might be looking for. These parameters are all the same age. Obviously,
Joe,
we use the same
people how to make the screen bigger. So on the widget for the media viewer, you can actually expand that or go full screen. There's a lot of detail that Joe's going to be going through, so that might be useful for those guys. Sorry, Joe. Sorry to interrupt.
No, thanks, Jeff. Matt, yep. Otherwise, out of the box, 341 ADS POP. See now, prior to 341, you guys could have defined the server cost. You would see it show up in shared memory, but obviously it would just do equal load balancing. I'm going to start my cut server cost 0. My cut server for cost 1. My ADS start script, right? I'm just exporting my ADS POP CNF file, starting up ADS 341. So in here now, you should see 4 servers. If you guys go through, obviously you can see in shared memory what your cost is, and then what's your max cache of each. So I'm going to run test client real quick. I'm going to open 500,000 items. Just kind of show you, remember on my lower cost groups, I have 25K on each. So around 95% of the 65,535, it'll start going over. Those familiar with TREP, again, you guys know we generate the load level internally. It's a percentage based on your number of active items and then your max cache. Something I kind of tell people that they don't realize that provider applications, RSL provider applications, can actually publish their own load level if they want. If we see a load level from the provider, we'll stop calculating our own, and then the provider then is in control of the load level. But generally, it's generated from TREP. ADH calculates it and then sends it across the backbone once a second. So the ADS kind of in the LAN mode only has a 1 second snapshot of the load level. Here in ADS POP, I'm able to calculate internally, so I'm doing every 10 milliseconds. So chances are with ADS POP, you guys will see, once you approach that 95%, you'll see even better sort of load balancing, more accurate load balancing than you would typically with traditional ADH and ADS. I'm going to run up 500K real quick, and then hopefully around the 95%, you'll see that it went everything to the lower cost servers first, and then starts failing it over to the higher cost group. For example, if I want to take say my local feed goes down. So I've got around just under 50K, 95% 50K on my locals, my lower cost group. If I bring down my local feed, my lower cost group, it should fail everything over to the higher cost group. And obviously, if I can bring up my local feed again, and then we don't have auto rebalancing in TREP, right? ADS POP is the same way. The load balancing layer, producer side, we'll call producer side the top half of the ADS POP is the same as ADH, so we don't have the auto rebalancing. But again, because we reuse the ADH logic on the top half of the ADS POP, we support the load rebalance trigger, where the administrators can go in and trigger the load rebalance. So you guys can go ahead and trigger that on the weekend or whatever you have you. Obviously, another mechanism would be to actually bring down the higher cost group routes. You guys could do that either through the monitor. So you could do that on a weekend as well. That if you had the capacity locally and you want to push everything back locally, you could just bounce those higher cost group routes, and then it would force everything back to the lower cost group. But as it is today, if you guys, again, if you just want to leave the routes up, you can certainly go in and trigger the rebalance feature that we have in the ADH and, of course, ADS POP as well. And then you'll see it'll start to load balance and rebalance off that server, the higher cost server that I triggered. Of course, all that's doing is just generating recoverable statuses internally. so that the consumer side can issue recall on that. Of course, when the consumer side reissues the recall, it's going to go back to the lower cost group.
Yeah,
so again, just another mechanism for you guys to go ahead and fail things back over to the lower cost group.
And sorry to jump in, Joe. This is Brian.
Sure,
there are a handful of use cases where we're leveraging this internally for our environments to help mitigate, ensure that we're consuming local content first in some of our environments rather than going to global networks, because we can weigh those routes differently. And there's also cases that our internal teams are exploring to mitigate disaster recovery requirements of their components and their products, leveraging this so they can have this point to ERT Cloud, for example, and have it cross different regions, so they can have their primary region weighted lower, so everything goes there. But in the event of failure or issues in that region, or just capacity being reached, they can go to another region or availability zone. So there's a lot of different ways this can be leveraged, especially with the combination of other TREP configuration. And then the routes that if you wanted to fail over, you could leverage even something like REST to bounce those routes now. So a lot of it could be scripted or automated a lot more easily with the combination of features that the team has been releasing in the past few quarters.
I could even, what would happen if I take down the higher cost group? Again, obviously, it's going to try to push everything to your lower cost group. Right now, because the way I have some capacity, my lower cost group can't support all 500K. And obviously, then it becomes an issue of whether you have preemption turned on and what you have preemption set to. Another small enhancement that we did to this release is we have a new preemption called unwatched. So those of you that don't want to ever affect watched items, but you still want some level of preemption, for interactive sync driven, you can set it preemption to unwatched, and it'll preempt anything on the pending age out queue. So anything that's unwatched, it'll kick out of cache and then allow you to satisfy the new request. So we use that internally all over the place. We thought it was a great feature for customers to have access to as well. I don't know how many people today use preemption. Everybody usually has plenty of capacity nowadays, but it just gives a nice sort of ability to still have preemption, but yet not affect actively watched items. So I took down the higher cost group. Right now, obviously, it's going to try failing everything over to zero. I'm going to eventually hit my 50K capacity, and then you're going to start getting preemption issues. Obviously, you could have preemption set to source app, and you let the source app try to reject. And typically, if you're cascading, obviously, then your upstream ADS is going to start rejecting based on idle limit or your limit from DAX. But in this case, I'm using test server, and I have the new unwatched preemption set. So right now, there's no unwatched items, so it returns unable to preempt. But as soon as I bring up my higher cost group with the additional capacity, at that point, then it should recover back onto the higher cost group. Because right now, you'll see everything is going to be on my recovery queue for unable to preempt, right? So the consumer side has some pacing when there's a capacity change like that. And again, because it starts coming up, it's going to reset all of its bitmaps as far as the request routing, but it's going to see the cost zeros is utilized. You're going to see all the servers are above the 95%, so it'll start feeding it back over to the higher cost group. I think we had a question yesterday, can you use this in conjunction with like non-recoverable polling? Right, that's what we do in ERT Cloud. So if we can't get it from the local is going to reject with a closed status, and then you guys can flip on non-recoverable polling and ADS pop to flip it to the higher cost group. Again, no auto rebalancing. That's up to you guys to schedule through the shared memory. Again, either bringing down the higher cost route or triggering the load rebalance feature through the shared memory. Any questions?
Joe, there's a question whether. Oh, sorry. Go ahead, Matt. I was gonna. One of the questions that came up was, can hash IDs be used with this?
Yeah. So all the partitioning that we have, obviously we're going to. The first part is going to look at the cost group, right? We're gonna find out what the lowest available cost group is that has capacity. So that's where we're going to go first. once we go there and we start going across the servers in that cost group that we chose, we're obviously going to start checking your regular expression hashes, right? So your partition list and your negative partition list. We're going to check the capability lists, right? So even if you have different providers, different capability lists across your cost groups, it's going to check that. It's going to check your hash IDs. Obviously, if it can't find a match in that cost group across any servers, even those utilization, at that point, it has no choice but to fail it over to the higher cost group. Typically, I would think when you're using this, you're going to have similar feeds across both your cost groups. If you're using it more of as a resiliency play, because if you're really partitioning, then you really don't need ALB, right? Because it's going to eventually find the server that you wanted to go anyways. But sure, it'll all work in conjunction if you guys want to enable it that way.
Thanks, Joe. Do you want to move on to
Sure.
the next demo?
Yeah, I got lots of stuff to show you guys, so we won't waste time here. Let me I'll rip down my environment here and I'll flip it to my conflation environment.
Just while you're doing that, Joe, we'll try and take as many of the questions. There's lots coming in, but we'll try and take as many of those at the end because we've got a lot to go through yet. We're not forgetting about them.
Sure. So level 2 conflation, requested clients, we have customers using their own internal custom domains, pushing maps to field lists. Obviously, we have Electron data that has this as well. The message rates aren't huge, but they're large. So there's a lot of processing resources behind the scenes there. So definitely now we want to support conflation of that. Today, obviously, we have field lists, but now we have aggregation of maps of field lists. We don't support other types, so all your series, vectors, filter lists, we don't have support for that yet, but we can do the maps of field lists. So we added a new parameter in 341 called aggregation domains. This is kind of like domains cached, same approach where you can define which domains you want to conflate. You can either put your numerical value in if you're using a custom domain, or you can just use shorthand that we use in TREP, market price, market by order, things like that. So, today in 341, if you guys want to actually enable aggregation, but disable it for level 1, but still leave it on for level 2, you can with this new parameter. Something I did not get to in 341 was traffic management for level 2. That's definitely on my hit list next. But we want to make sure we get the standard conflation out for you guys. Works with item threads, of course, works with MQS, of course. We're going to send you guys a table that kind of documents our rules. Perhaps these rules don't all work for everybody, but these are what we use internally within the ERT. So we try to keep it similar with TREP, but I think they're pretty straightforward. But if anybody has any feedback once they start playing with this feature, obviously please send it to us. But this kind of goes through all the different scenarios you guys have. So while we're conflating, if we get an add or update or delete event for a map entry, how do we handle that? Now that you're conflating, obviously you could see a conflated update with the same map entry multiple times. You could have an add or delete in the same conflated update now. But as long as you're following ESDK documentation, an RDM usage guide, how to decode the map, decoding your map entries in order, there shouldn't be any problems with that. So, real quick demo here. So again, out of the box 341, real quick to configure. I pretty much have this just a single route. I captured some level 2 data from our ERT cloud service the other day. So I'll kind of show you guys playback of that. Those of you not familiar with the binary capture and playback with RMDS test server and RMDS test client, that's what I used, right? So RMDS test client, you can open up and specify a binary capture file, and then you can take that same file and play it back in through RMDS test server. And so we use that all the time, and that's what I'm going to show here. But in the ADS POP CNF, we have obviously the update conflation section. So here's your update aggregation. Here's your aggregation domains. So I have 6, 7, 8 right now, and then your different aggregation intervals. For level 2, we do not support right now the aggregation fields parameter. Again, something on my hit list. I think in the future we could probably look at summary data for that and then determine, based on prod perm or exchange, whatever is contained in your summary data, whether or not you want to conflate that item or not. But today it's at the service level only. So I think that'll hit everybody's use case for now. If you need that aggregation fields level control, then let me know and we'll get that put on the enhancement list as well. So today it's service level. Right now I have aggregation off. I'm just going to kind of show you guys some of the data and what it looks like. Maybe those of you not familiar with level 2. So I'm going to just run up my RMDS test server with my data that I captured the other day. So test server, I captured this L2 capture.dat, and then I'm just going to feed it back into the RMDS test server. And then, you just open up the RICs that are in that binary capture, and then test server will play it back. And then you guys can specify in test server in the interactive menu the rate that you want to play it back. Obviously, you can enable global update order. So there's a timestamp in our capture, so you can it'll actually space out the updates based on the timing that the test client captured it. So very, very great feature. So let's see how many images I loaded up, how many updates I loaded up from the binary capture. I'm going to flip my ADS to my conflation config. Again, remember, I don't have conflation on right now. I just kind of wanted to show you guys kind of what it looks like. And then my RMD test client command, real simple, right? I just have an enhanced item file. Those of you not familiar with the enhanced item file, what you can do is you can put different RICs with different domains in there. So you can put your domain, and then we have a deliverables pipe, and then you put in whatever RIC name you have. So I'm just opening up 5 items, and then these are obviously available from Electron today. And then let me dump the XML for you. So again, it's multi-part. I'm only opening 5 items, but as you can see, there's 138 multi-part responses for those 5 items. In this case, I'm just going to dump them to XML. And then test server right now, I don't have a replay rate set. It's 0. So right now, it just plays back the initial image responses. And then from the interactive menu, you can just play with the replay rate. So replay rate of 1 will just start pushing the binary file exactly as RMDS test client captured it. So you can see right now I'm pushing 1720 updates a second. Average update length, 300 to 500 bytes. If I look at RMDS test client, you guys can kind of see what it looks like, right? Map of field list. Now, obviously, it's binary on the wire, but this is just run through an XML decoder. So you can see right now, obviously you won't see any conflation times or conflation counts. Those of you who don't know, you can actually request conflation count and conflation time information through RSL. So you can actually, in the request flags, you can say, I want conflation information. So it's very useful. Obviously, then you can see your counts and times for each conflate update that you receive. So right now, you'll see smaller updates. You probably won't see the same map image twice. Usually the headend won't do that. And then you guys can kind of see my update links. So what I'm going to do now is I'm going to turn on conflation. And we'll go a little crazy here. We'll make it 5,000, so 5 seconds. And I want to show you guys the kind of the effect on the message sizes. And obviously, we all kind of familiar with the conflation. We know how it's going to affect the rates usually. But obviously, you have level 2 data, live level 2 data. I'll kind of show you how it affects the sizes as well. So we'll see the image responses, but obviously every 5 seconds I'll get complete updates for each item. Obviously here, again, we're still dealing with that 400, 500, 600 bytes per update for the tick by tick. If I start looking at my conflated updates now, they're going to be large, right? You're talking a K probably a piece just because we're aggregating all those entries into the same update now. Obviously now you're going to see conflation time. You're going to see a conflation count. And again, as you go through, you're going to see more and more aggregation of the map actions, right? Now, check the table. We can go ahead. We can optimize out, right? So if we get an ad, delete ad, we can kind of optimize some of that stuff out and whatnot. And we try to do the best we can, but obviously we want to preserve things as we have to as well. So if you guys want to take a look, we'll look at the standard stats output from the test client. And I can kind of jack up the rates now a little bit and show you a little bit more how it's working. Right now, obviously my update rate's really low, 5 seconds. But you can start to see how your data sizes are increasing now because we're aggregating all those map entry actions. This is a new feature I added to test client. Unfortunately, I didn't get it in for 341, but I'll show your average conflation count and your average conflation time. And through test client, you can actually request that. You got to request it today. Maybe I'll change it so I default it to RF16, but today you've got to specify the RF16 flags on the command line to get that conflation information. But here you can jack up your replay rate, and obviously it's going to affect your data sizes now, right? Because we're looping through more and more data, we're pushing more and more map entry actions, so we're aggregating more and more of those. So obviously now you can see your large completion counts and your large completion times. So any questions in level 2? Otherwise, I'll show you guys a couple other enhancements that we did while we were at it.
I think we'll move on, Joe. Just for the sake of time, we'll take the questions at the end.
Okay, sounds good. So while we're in the code, a couple other things we noticed. Anybody that's been around conflation for TREP may or may have not noticed a lot of this stuff. But right now, previous versions, we only had 100 millisecond granularity. We internally, and we've gotten a lot of requests for feedback as well, wanted it down to like 330, right? We want to get that 330. That's typically what we do in our head ends and HMDS. So we want to be able to do that, match that in TREP. So we turned it down to 10 millisecond granularity. I left the default as 100 for everybody. I think Mahesh said there was a couple customers asking to go lower than 100. What we did is we changed the timer interval from 50 milliseconds down to 10 milliseconds. So in theory now we should have no problem going down to 20 milliseconds if that's something that somebody wants. Something else, which probably we never advertised, but those of you who maybe paid attention have noticed that our accuracy will slide, especially at longer intervals as you go. I'll show you guys here with 340, but at 5 seconds, we're firing off 100, 120 milliseconds early. So we think that was not the greatest scenario. So we definitely improved the accuracy. So while we were bringing down the timer interval, we now associate and we calculate that clock drift, and we'll reshift every 10 milliseconds. So hopefully now it's consistent across the board. You'll fire within that 10 milliseconds. Now we do a bucketing system, but then when we roll in that final bucket, again, we'll always try to fire early. We'll never try to go past, so we'll fire within that 10 milliseconds, but much improved over previous versions. So if you guys are really trying to manage your message rates, and your message rates are getting a little crazy, wacky, not what you're calculating, it could be because of this, right? And then upgrading to 341 should hopefully make it very easy for you guys to calculate those rates because of the improved accuracy. So what I want to do right now, I'm just going to run up a level 1 test. And then I'm going to show you we're kind of a bad scenario here, how bad we are with previous versions. So again, 5 seconds, I'm going to start up an ADS 340. I'm just going to open up 3,000 level 1 items. And I'm requesting the conflation information. Again, remember, this is 340 here. So you can already see the conflation times are not perfect, right? We're firing more than 15 milliseconds early. Again, I've seen it go below 4900, 48, whatever. So just to give you guys a quick comparison of what 341 looks like in the same scenario. And hopefully we're within that 10 milliseconds now. And every fire should be within 10. Hopefully we won't slide like we did before. So now you're 49.94. So all of them should be in that 49.90 range. Now, obviously, again, as the longer aggregation intervals, they'll be more prevalent, but it's even prevalent down at the lower intervals. I'll show you real quick as well. So if we went down to 330, we try to go down to 330. And just flipping back to 340, I'm going to show you guys the previous behavior. What 340 is going to do is it's going to round down to 300 milliseconds. Again, it didn't support that granularity of 10 milliseconds. Same test case. You know, I'm looking for 9,000 updates a second, right? 3 updates a second for each item. Obviously, you can see I'm not there. I'm going over. I'm going over because I'm firing early, right? I'm firing under 300 milliseconds, 280, 290 range. And this is at 330 specification. Just to run a quick test again, what 341 looks like. Same exact test. Hopefully we should be within that 10 milliseconds of 330. And then hopefully, you know, now, because I'm accurate, I'm not sliding, I'm not drifting, I'm getting my, as predicted, 9,000 updates a second. All right, that's all I had for conflation.
Great, thanks, Joe.
Yeah, sure.
I think we're just going to also touch upon the node lock license mitigation as well. So, Jeff, did you want to maybe give a quick overview of what that is? I'll move to that slide just while Joe is setting that environment up.
Sure. I don't think it's a surprise to anybody who's had TREP to realize that these are node lock licenses that require IP address and a host name when you set this up, when you configure the license file. This works well for everyone except for AWS customers that are not using Docker containers. So we are not the first vendor to have node lock licenses. So what Amazon has come up with to address these node lock license issues is all you have to do if you want to run ADS POP at AWS but not in a Docker container is you're going to create this elastic network interface, ENI, and there's a link here, very well documented process to do this. It's not difficult. A user guide that will walk you through the details. And what the ENI requires, though, the ENI requires you to use an IP address and a MAC address. Well, obviously, we require IP address and a host name. So what we have done, what Joe has done on the development side, is now we have 3 parameters that you would be using to set up a license, but you only need 2 of them. And you will continue, everyone that is not running Docker containers will continue using the host name, and you can use either IP address or MAC address. However, for the ENI will require IP address and a MAC address, but not the host name. So what happens is you set up the EC2 instance as you normally would, but then you're creating the license within the ENI itself, and the ENI is tied to the EC2 instance. So in effect, what this means is you can have, you have the ability to not need a host name where the node lock license no longer causes a problem for you by simply using an ENI. The ENI, again, separate and distinct resource to the EC2 instance. And this is the way Amazon's designed this to address the node lock license issue. So very simple to do. It took a little bit of effort. There's a changing in the parameter, which will require you to download or install 341, right? And again, just a refresher, you will now have 3 available parameters. Anyone other than users running at AWS that are not using Docker containers will simply use the private IP and the MAC address, and all other users, whether your containers are deployed, will continue using host name, but you can then choose to use either an IP address or a MAC address. So it's really that simple. And that resolves the challenge around licenses.
Yeah, we get constant feedback about licensing. Of course, everybody is, worried about licensing. So one of the feedback was, as Jeff says, so the ability to use MAC address, obviously we haven't supported TREP on Windows for a long time, but Windows today uses MAC address. So that was one change we wanted to make, to give it the flexibility to use IP or MAC. So the node ID generation scripts that we send, we added a --MAC option now. There's no changes to the request processing or TRLMS. TRLMS, you just feed in that 8-character sort of hexadecimal number. I'll kind of show you guys how the node ID scripts have changed, but no changes to the front end. It just uses MAC or IP. And then before, technically uses the Linux host ID, which is tied to the IP. Another change that I made was it only would use the IP off the primary interface. So for this scenario, especially for EC2, I want to be able to attach a secondary interface and then have it pick that up and match it for licensing. So I had to change it as well, not to just look at the primary, but also loop through all the available non-loopback interfaces to check for the IP or MAC, depending on how you want to use it. And then as Jeff said, obviously EC2s or any cloud environment, where you're not running containers, obviously your host name and your primary IP are ephemeral, right? We want to take down every 3 months, brand new blue-green, brand new set of host names and primary private IP addresses, right? So how do we solve that? So the first thing was obviously we had to get rid of the host name check. From our standpoint, we're still good because you can attach the CNI. It's still one-to-one with your EC2, and it's a permanent resource, right? I'll show you guys here. You create the network interface. It's free on Amazon as long as you have private IP addresses in your virtual private network. You're good. You bring down EC2. It automatically detaches, frees back up to the pool. You bring up a new EC2 and you reattach the ENI. I think you could probably even keep one license file that has all your ENI information inside the license file. So your cloud formation, your deployment is as easy as just copying over your license file and then attaching your ENI. I'm going to show you through the console, but again, it can all be done through command line when you spin up the EC2 instance. You can make it work prior to 341, right? You could go through the trouble of changing your EC2 host name, which is possible, but it's a difficult process. And then as well, you'd have to override your primary interface with an elastic IP, which is again another resource you can create in Amazon, but it requires an IPv public interface, and they aren't free. So this is a free option. You can simply attach and go. So what I did in Amazon here is I just created a basic EC2 out of the box. Obviously we would like to see you guys use our ADS POP AMIs. Hopefully that would make it easier for you guys. Obviously with our ADS POP AMIs, there are running container. There's no licensing issues there. And then you can have the option to connect to ERT Cloud, or you can pass in your own configuration files. So hopefully that's the easiest route for you guys to go. Obviously we also have ADS POP containers directly in Docker Hub. So if you want to build your own AMI, quick plug for a Docker Hub. And if you guys have any feedback on that, please send it my way. I know internally we've gotten some feedback on our Docker approach and whatnot. So definitely we're listening to that feedback. And as time goes on, we'll continue to hopefully work that feedback in. But this is just standard out of the box EC2. I've already downloaded the ADS software. But as you can see, obviously my host name and my IP address are ephemeral. So if I go ahead and I try to log in to my EC2s, you'll see right now I have my primary interface, right? That's the interface that Amazon's going to give me, the MAC and the IP. I don't have much choice with that. But what I did is I went back to Amazon now, and of course, if you try to start the ADS, you'd have to create a new license file every time you spin up a new EC2. Nobody wants to do that, right? We want this thing to be quick and easy. You guys don't want it to go every 3 months when you tear down and build back up to request a whole new set of license files. So that you could make it work that way, but obviously that's not a long-term solution. So what I did here is I created a E&I. I'll give the screen some time here to refresh. So again, it's real simple to create one. You just come in here and you create an interface, and then you just give it a description, your subnet of your VPC, and whether you want AWS to allocate the private IPs and MAC, or do you want to do it. In my case, I just created one. I said, yeah, AWS just assigned for me. And then AWS never changes that, right? It's a resource, and right now it's available, so it's not attached to an EC2. But now I have a static MAC and I have a static IP address that I can use to request my license files. So for every ADS POP that you want, you would create an E&I, and then that'll give you an IP and MAC, and then you go ahead and you can request your bulk IPs or MACs, depending on how you want them. So that's what I did, is I took that private IP and private MAC, and I enhanced our TREP container script to now optionally take an MAC address. So you can stay IP. In the E&I case, it really doesn't matter. IP and MAC are both static, so kind of whatever direction you want to go. What I did is I actually then wrote a script to do both, right? So I'm just calling my TREP container node ID script. For hostname, it can be anything. For me, just to keep organization, I named it the same as my E&I. But again, when running EC2, we don't even look at hostname anymore. So it's really for housekeeping purposes, and that's what I like to do is name it the same as my E&I, just so I know what that node ID is associated with. And then you guys can see the corresponding license files that I got back. Obviously, it just contains Miller E&I, but then it contains my IP address, host ID format, and then obviously my MAC as well. And again, the licensing system's none the wiser, but it's still tied to hardware. So when you use MAC address, like I said, it's similar to what we did for Windows, where we would use MAC address for Windows. Obviously, TREP's not, but I think maybe DAX still is, and ATS. So, but that's great, right? But it doesn't help me right now because I'm still stuck with my primary IP. So I can give it this license file that I created with my INI, of course, but it's still going to fail, right? Because the box doesn't know about that IP or MAC yet. So of course, I try to start the ADS at this point. It's going to fail. Okay. So if I go back to my console, and then I select my ENI, and then I say attach. Now, I wish Amazon had a little bit better way of filtering EC2s here. But again, if you build this part of your CloudFormation, you don't need to do this in the console, although you can if you're only doing a couple. But now it takes me a second to kind of figure out where my running instance is. So you select your instance, and you just say attach.
And like you said, Joe, that can all be done through CloudFormation dynamically, so you don't have to go through the manual steps of attaching it if you don't want to. If you're setting up an environment that you want to prop up using CF or some of the other orchestration tools out there, this can all be done through those.
Yep. And then once you attach it, in the console it'll show up as in use. And then there's no option to be able to attach to a second interface. Now you can attach multiple separate ENIs to a single instance, but as far as ENI, obviously it's assigned a private IP address in your VPC, right? So it can't assign it to another running instance at this point. So if we go back to our EC2 now see I have an ETH1, right? So that's where it put the ENI. So as far as your EC2 is concerned now, you now have an IP address or a MAC that hopefully matches your license file. So now if I go back and run the same thing, try to start up my ADS, fingers crossed, it should start. And there you go. And I just connected up the UP cloud just now. Now I've seen all of our license statistics show up. You're good to go. That's something else you can do. Amazon will do it when you destroy, or say the EC2 gets destroyed, so you go back to your EC2 and you just say terminate. It'll automatically unattach the ENI for you to free it up to allow you to attach it to a new instance. Or from the console, you can go ahead and you can unattach manually. So just go into actions and then just say detach. And then hopefully our status goes back to available. And again, I'm doing this with the running EC2, so it takes some time to attach and detach. But again, if you're doing this part of the CloudFormation, your stand-up EC2 and the association of the ENI will be at the deployment stand-up time of the EC2. So you can see now my status shows up as available. Now I can attach it to any other running instance I want to at this point. So if you want to transfer, you had an EC2 running that you wanted to move an ADS pop. Obviously you can just detach, move your license file over. You don't have to touch your license file. Use the same one and reattach to the new EC2, and you're up and running. And now, I guess in theory, it's a way that administrators could actually disable somebody's ADS pop as well, right? If somebody's running an EC2 out there with ADS pop and you wanted to take away their licensing abilities, you could do that through the console. Because now if I go back to my ET2, you'll see ETH1 was taken away. Now I won't be able to start the ADS. So we hope that'll work for all the customers that we have. Again, on-prem stays the same. Container stays the same, other than adding the optional IP or MAC. But for container and on-prem, it's still host name. So we didn't make any changes there. Just when we're running an EC2 is where we're going to go ahead and disable that host name check. And again, the other enhancement was to scan all the interfaces. So even on-prem today, if you had to add a secondary card or something like that, and you wanted to tie the license file to the secondary card, you could do that with the software today. Which Windows was already doing that, so I'm kind of surprised we didn't maybe originally do that out of the box, but we're there now. So end of the month, and you guys can take advantage of this.
Joe, thank you very much for that. I think that was an in-depth update on the license mitigation. So hopefully a couple of questions popped in, but again, we'll park those until the end because we're running a little bit behind time, and we've got Mahesh who's next up. So you want to stop sharing your screen, Joe, and I'll move the slide on for Mahesh. Thanks very much for that, and you'll be ready in your Hawaiian shirt for questions at the end.
Sounds good.
Speaking of Hawaiian shirts, you may notice a little bit different with Mahesh. He very subtle Hawaiian shirt blend he's got. So Mahesh, I'll pass the microphone over to you. Let me know when you want me to move the slides. And also take yourself off mute, possibly. Not hearing you yet, Mahesh. Probably triple muted yourself somewhere. There's about 3 different control panels we have to use to unmute ourselves, so he may be struggling with that. Just while he does find his unmute button, the presentation that Mahesh is going to run through now, again, this is a sneak peek of what we'll be doing in much more greater detail as part of the upcoming 3.4.2 release towards the middle of the year. So this isn't meant to be an all-encompassing. It might give you a couple of ideas where to start looking, and then if you want the full event, then we'll be scheduling that in the upcoming months. Mahesh, do you want to try again? I can't believe we went through 3 live demos which worked. We can't get this working. Okay. While Mahesh is trying to sort that out, let me bring up a quick question which may or may not be relevant, but I'll push this out now and you guys can have a look at this just while Mahesh is sorting himself out. So what you're going to be seeing from Mahesh is around some of the performance tuning. Equally so, the test scope we currently have is for ETA providers, ETA and WebSocket consumers. In addition to that, do you want to see coverage for any of the following? SSL market feed, provider or consumer, both SSL market feed provider and consumer, or you're no longer interested in SSL market feed at all? So again, anonymous polling, but if you want to put your, click the button that you think is most relevant and we'll have a look at what the results are. And then hopefully we'll be bringing Mahesh back.
Hey, Matt, can you hear me now?
Mahesh, I can, Mahesh. Yes, I can.
All right, good.
All right, let me hold on tight. We'll just get this result of this this out,
Sure.
and this might influence your presentation on Mahesh.
Yeah, no problem. This good one.
Okay, the votes are all rolling in. So again, SSL market feed provider, SSL market feed consumer, both or none? You can imagine this might be a little bit of a loaded question in terms of what what our performance testing might incorporate. Okay, so let me move to the results and we can have a look. We've got a good number of results already back in for this. So I don't really know how to read that one, Mahesh. You've either got both or none, which might not help you at all. Okay.
Well, that's fine. I think the majority seems to say they would like to see both. So we'll factor that in.
Okay. All right. Thanks for that, guys. We'll switch over to your slide now, Mahesh, which is the preview slide.
Okay. All right. So. Yes, thank you, Matt. So as part of this ADS POP performance and the tuning guides that we are working to release this quarter, so we will use our reference platform as the Gen 10 and with Red Hat 7.x. We released a document last year for TREP 3.3 with the same platform that focused on the RRMP, ADH, and ADS. So that will give a good reference for this work as well. And we will cover all the 3 threading models. As many of you know, the ADS POP threading model started with just having the main thread do all of the work of getting the data from upstream, caching, conflation, all the features, and the last mile delivery to the client applications. So that was the lowest latency mode. And then we added writer threads about 10 years ago, beginning with threads. So the main thread still does the upstream communication and the caching of the data, the client communication, the conversion to WebSockets, the compression, all those features happen in the writer threads. And then that's the second model. And then the newest one that was released and started to be supported since about middle of last year, introduced item threads. So basically the item threads now take the role of the main thread. The main thread is still there to make a connection upstream and to do some of the synchronization of the source directory, but all of the data now flows through the item threads. So the goal is to cover all of these threading models, give various examples, use cases where it may be important to increase the item threads, what is the functionality of each thread, and how does it fare when you introduce various scenarios. So we will do at least 3 major themes of test. One is obviously we want to identify what is the maximum inbound message rate the ADS POP can handle. As Jeff mentioned earlier, we are seeing more and more adaptation usage of ADS POP. And so there are certain scenarios where the ADS POP is kind of the top level POP, where you have your caching and conflation and functionality there, and then a lower level POP, which is more for distribution. So depending on that, you have different needs. So the tests will identify those scenarios and, maximum inbound message rate and the maximum number of connections for the other scenario. So in the past, we had a couple of test cases where we had our producer 50-50 model, which was really a fan out of 50. And then we had our full fan out, which was a fan out of 100. So I think whereas that is still important in some use cases, the number of connections is probably far more important for our customer base, and that is the feedback we received. While doing that, in conjunction, we are going to observe some of the bandwidth limitations. So the ADS POP, just like the traditional ADS LAN, is highly performant. It can drive multiple 10 gig cards worth of traffic, but that may not be the common deployment scenario. So in this round, we will include numbers to show for each 10 gig how much you can get out for an ADS POP. So that will help size, how many cores you need, depending on if you are bandwidth constrained or not. So that's the high-level view of what we are trying to achieve. So Matt, can we please move to the next slide? So, okay, so as far as thank you, Matt. As far as the topics, so we will certainly have some of the system tuning information. As many of you know, with the HP Gen 10, there is now a workload profile. So we don't have to look at each of the BIOS options as a knob to tune. So we can use a profile-based approach. This is similar to the Red Hat, going back to the Red Hat 6 days when they introduced profiles. So you can say, okay, my workload is more based for throughput or latency or virtualization or storage or whatever the case may be. So that will be covered as the beginning, and then the differences of threading model concepts, who does what, as in which threads does which functionality, and the bandwidth limitation. So we get, assuming our standard 24-byte update message size, we get about 13 to 14 million messages per second using a single 10 gig port. So that's important to understand, because there are use cases where we have no more than one card, dual port, or 2 cards, one in each NUMA node. And depending on that, you can size your ADS POP differently. You can decide on how many threads you need. So that's an important consideration. And the message packing. So if you do full message packing, obviously that's helpful, but real life may not actually be full message packing. So we will include some examples to show what is the impact of message packing. And the NUMA effect, obviously, it's always there. So if you can fit everything onto a single NUMA node, that's the best performance. But if you have to go across the NUMA node for different reasons, depending on how many threads are necessary, then there is, from preliminary numbers we have, 7 to 10% cost of going across the NUMA node with some of the tests we do. So that will also be included. And some of the tools we use, the IPERF for understanding the bandwidth, NetStat or SS, that's a new tool in Red Hat 7 for socket statistics. And then, the LS CPU, the LS Topo, the NUMA control tools that are used for understanding the machine architecture, and then our own tools that we ship as part of the TREP, the ADS-MON, test client, test server, as we use in some of the testing and also for component monitoring. That is one of the next topics there. So using ADS-MON, there are a whole number of variables there to see how each thread is doing, what is the update rate, what is the packing, what is the compression ratio, whether there is any resource contention that we can spot through session blocks, as an example. So there is a whole number of variables that are important for monitoring the health. Then I think we also have the round trip time that is tracked through the ADS-MON, now beginning 332 or 333 since last year. So that is there as well. So there are a number of variables that are helpful in understanding the health and also in establishing a baseline. So all these things will be covered in the tuning guide. As far as the specific tests we are going to do, we will do the update throughput. We will do the image retrieval. Snapshots is something that a lot of people are interested in knowing. So we will have to do the thread and process binding for each of these things, and also the recoveries and how long it takes to recover a number of items under different load scenarios. And the upcoming warm standby functionality will help a great deal. But we will have examples to show with and without. And the cost of compression, zlib is the only supported compression algorithm for all three connections, RSSL, SSL, and JSON, simplified streaming. But for RSSL, we also have the LZ4. So we will share the cost of compression and how do we test for it. One is to do tests throughout the day through live data, and we have metrics in the ADS-MON that we can just grab, whether using the REST call or just using the old methodology of ADS-MON minus get, so we can get that. And also the cost of encryption, because that's a new feature that was added in 3.4.0. So these are the things that we have as a scope to cover. And thank you for the feedback about having the need to include SSL market feed provider and consumer. We will certainly do that as well. Next slide, please. Okay, so some of the preliminary results are available now. So what we are trying to do is to lock down certain configuration. And one of the things in this example is we use no more than 8 cores for the ADS POP. So that kind of fits nicely into a single NUMA node. And also, that's an easy to instance size. So you can see how much can you get out of that. Sorry, I'm not seeing that slide. So we have different examples there. So we always enable the cache in the ADS POP. So if you just use a main thread plus a number of writer threads, what is the message rate we can achieve? It's 900,000 updates per second, assuming 2 routes, 100K watch list with no commonality. And as we increase the item threads, if we include 2 item threads, we can go up to 1.6 million updates per second. If we have a different use case where it is more important that we have a large number of incoming messages and a small number of connections, but large consumers, we can flip that and we can go with 5 item threads and 2 writer threads, and we get 3.5 million updates per second. So we will include different numbers, not just the best number, because that will. And we also, since last year, we have been including the output of top. So that shows you on a per thread basis at different workload how much the consumption is. So that will help extrapolate, if your threading model, the number of item threads, writer threads slightly changes, coupled with the cost of the NUMA. So that's another example that will be included. So that will give you a good idea as far as the deployment goes. So that's one set of tests. And then the Other one is the compression efficiency. As a simple example, we took 5,000 active ERT instruments and I did the measurement with the live data throughout the day using zlib level 3 so that we could compare how much compression we can get. And we could get 70% compression for RWF, which is a binary data format, which is quite nice. And, simplified streaming WebSockets is ASCII, so we could achieve about 90% compression. So one thing to keep in mind is, when we have to measure the CPU impact, we'll have to capture a large data file and play that through using the test server with the replay limit options that are there, so that it is not, amazingly great, like 98% or something you will see if you just use a sample XML. We want to be more realistic. We just want to use it with live data as far as the test goes. Matt, can we please go to the next slide? So there should be an example usage.
Yeah.
Okay, so this is how the test was done. So we captured live data throughout the day, and then in the ADS mon, there's a compression ratio. And then you can also cross-verify with the test client to see what is your message size, and do a test with and without compression connecting to the same ADS POP. And so that's the compression ratio we saw with live data. Compression is highly data dependent. Obviously, you will have to do your own testing, so we will include the methodology. So yeah, there will also be a small section or a separate document about the testing methodology. So it will be covered either in the tuning guide or as a separate standalone document. So may I have one more slide? Can you please go to the next one? Yes, so thank you, Matt. So yeah, so this is the other test that we are doing in identifying the number of connections and how many connections can we handle given a certain threading model and a watch list. So we have to fix the watch list size and the expected inbound message rate. We assume 100% commonality. This is an example where we are using no more than 10 Gbps. So it's a 10 gig card dual port, but we are using one port for the northbound connection and one for the southbound connection. If it is the final leg of the distribution, if you assume a small watch list like a 5K, what we see is, yes, you can do 900 connections within our total 8-core NUMA node boundary. In this case, we are bandwidth constrained. 13.5 million updates per second is the number we get with our 74-byte messages. The writer threads are under 70% CPU utilization. What we need to add to this is, okay, what if you are doing the compression? So then you have extra bandwidth to go, but your writer threads are going to work harder. So there is a cost of compression. So that will change how many connections you can handle, or you can increase the number of writer threads. So that's the kind of examples that will be shared. Or you can also take a bigger watch list size and assume, how many connections you make. And then, you can, if you assume 5 connections, then it could do, in this model, 800,000 messages in, 4 million messages out. So we could see that the item threads were maximize 90% or so in the utilization. So if that is the kind of model you want as a parent POP deployment, then you will have to increase the number of item threads. So that's the direction we are going in. So if you have any feedback or if you would like to see something else, conflation is certainly included as part of this through the MQoS. Any other feedback you have, please send them our way. We will make sure to address them.
Thanks very much,
Thank
Matt.
you.
We have one question pop up that might just be useful to answer now. It was, will the ADS POP performance tests include channel threads if supported?
Okay, so we do not support channel threads in the ADS POP. So in the ADH, we have channel threads driving the item threads, and then the item threads go to the backbone through the DLT. In the case of the ADS POP, the threading model is we have a bank of item threads at the top, and then the writer threads at the bottom. So the main thread is kind of on the side along with the item threads. So the data transmission is through the item threads in this case.
So maybe a follow-up question also appeared was, what method do you recommend to CPU bind the minor POP threads that are not detailed in the CPD file?
Yeah, so ADS POP, yes, ADS POP is something that wherein you can bind every single thread using, you can bind main thread, you can bind item thread, you can bind the writer thread, you can bind the DNS thread, you can bind the AGMO stats thread, you can bind the REST thread, each one in its own. But in addition to that, we also have a thread binding by default kind of an option. So you can say, okay, I'm more interested in binding item threads and writer threads. That's where the message flow is. But I don't want the other threads to be interfering for any reason. And you can use the thread bind by default option, and you can bind them all away that way.
Okay, thank you very much for that, Mahesh. Now, we were going to have a polling question about who had the best Hawaiian shirt on, but we'll skip that one. And we'll move across to Jeff, who's going to go through the second page of the roadmap. So let me click on that one. Hopefully everyone can see the second page. So Jeff, do you want to run through this quickly and see if we've got 2 minutes for questions at the end?
Sure thing. Thank you, Joe, for the demonstrations and the effort for getting the solution for mitigating the node lock licenses resolved this month very quickly. Thank you. And Mahesh, thank you for also the quick thinking of your getting audio connection. Important. All right. So anyway, we left off in the third quarter. So I'm up to the first one here on the top of page 2. It's Red Hat category A support for Red Hat 8. This is going to be pretty simple and quick. I know we're running late here. Benefit Cat A support, really simple, will allow you to take advantage of new performance, scalability, and security features that Red Hat offers. So that's Q3 we're looking at. All right. Home stretch now, fourth quarter. I'll go quick. Basically, extend the ADS POP to Azure and Google. Obviously, the benefit is to become more cloud agnostic. Our customers want more alternatives. Obviously, we went to AWS first. We were pretty well established there. We've been using it ourselves now for a year and a half there, so we know what's going on. There is some work to do with Azure or Google, but we're anticipating things could go smooth, so that's fourth quarter deliverable. Next one here, which is the 9th one down here altogether, level 2 delay. We expect basically we expect to extend our delay feature to level 2 today by extending quality of service parameter to all the domains, including custom domains. So it pretty much covers everything. Benefit anytime you have delays essentially is to reduce exchange fees wherever possible for these additional data sets. Going on beyond just plain old level 1 data. Right. Next to the last, level 2, cache persistence and resilience. This is a feature we have today for level 1 data. So we're going to be extending this to level 2. Level 2 data will also include all custom domains. So basically what it does, allows us to synchronize cache of level 2 across all providers, and the benefit will be faster recovery on any restarts. Right. And the last one I'm going to hit on here is the small enhancements. I should have probably said this earlier. I normally say it, at the CAF. People at the CAF are sick of me here and saying it. But there are many new people that don't realize this. What we consider to be a small enhancement is anything that takes less than 6 person months, and any effort that takes 6 to 12 months is considered a large enhancement. So normally, we're delivering, 2 or 3 large enhancements per quarter, and somewhere around 10 to 12 small enhancements over the course of the year. So all the details for every delivery that we do is posted in a What's New document. It provides a list of the large enhancements with a description of small enhancements, along with a list of bug fixes. So there's one, I believe, available to you here today as resources. It's also posted on my Refinitiv customer zone for those that you remember that. Usually I just want to give one shout out to Joe. Normally there's 8 to 10 bug fixes per release. This whole idea of everybody having to stay home and work from home would lead me to believe, for Joe's people, this trip to the office is way overrated. There are 30 bug fixes for this release. So shout out to Joe for getting a lot done under the circumstances we're all working under. Thank you. And that's it for me, everyone.
Thanks very much, Jeff. I was going to go and try and get through a couple of the questions, but really we've only got 1 minute left. We're never going to address all of the questions, I think. So maybe we'll just spend this time to wrap up. And then hopefully what we'll do, we'll go through those questions, the questions that we like or that are easy, and we'll respond to those separately. And we'll get back with an email back out to all the people that have dialed in today. I just want to say thank you to all of the people that have been presenting today. Apologies for a couple of the technical detail or difficulties, but we're almost over that hump now. So hopefully you've all got an idea of what we're delivering in 341, 342 and beyond that, and understanding our ongoing commitment to the platform. And hopefully you've also seen something today that might make you want to go and play in your lab, download the latest software when it's released shortly, and experiment with that. Certainly from the amount of questions we've got, everyone's really, really engaged. Some really good details in there. So I say we'll get back to you on those. Once we've all hung up, you will receive a follow-up email with a link to the recording. So if you do want to share that or replay any of the highlights to your friends and family, feel free. Also, make sure to fill in the feedback survey that appears once this webinar is over. And if you want a call from specialists, then fine. Or if you want to drop an email to the other people on this call, then that's fine. We'll have that in the deck that we'll also share with you. We just continue to want to make these better, make them engaging and useful. So please do let me know. And I want to say thank you very much. Enjoy your day. Stay safe. And we'll speak again soon. Goodbye.
Goodbye. Thank you, everyone.
Thanks, everyone.
There you go, everyone. That's the end of the webcast.
Nice job, everybody.
Great job. Well done.
Great job. Yeah. Sorry, guys. Sorry for the audio trouble.
I said I can't believe we got sorry live and then had trouble with audio. It was
I thought that was funny. One of the most technical people in the group has trouble with his audio. How can that happen?